Hi everyone! Welcome again to my channel, Math is Fun channel. Again, this channel is an educational channel to help you understand your lessons in mathematics. This is also intended to those who are doing the online classes out there and also those who are answering their modules out there. Hello! This is very helpful for you to understand your lessons and of course to improve your performance in mathematics. So please continue to support my channel and subscribe my channel and share this one to your friends, especially those who are struggling out there. Is that okay? Yes, that is okay. So we will go over with our discussion in this video discussion. Yes, in this video rather. So we have it. Of course, our discussion will be about quadratic equation, the introduction about quadratic equation. So now here are the objectives that we have to follow in this video discussion. Of course, we have to review in quadratic equation, we have to review the zero factor property. Because after discussing the quadratic equation, we are going to solve the roots or finding the roots of quadratic equation. Second objective, we have to solve equations of the form of x squared is equal to k, where k is greater than 0. So no negative numbers in your k. For number 3, solve equations of the form of quantity ax plus b closed quantity squared is equal to k, where k is greater than 0. And lastly, we are going to use formulas involving squared variables. So that is so exciting. Again, lastly, we're going to use formulas involving squared variables. So to start with, of course, solving quadratic equations by the square root property. In this section, we solved quadratic equations by factoring. Since not all quadratic equations can easily be solved by factoring, we must develop other methods. Are you excited about those methods? Yes, we're going to tackle about other methods aside from factoring in solving quadratic equation. So first objective, we're going to review the zero factor property. So we all know, or yes, as I recall, we all know that the quadratic equation is an equation that can be written in standard form. As you can see, the standard form, ax squared plus bx plus c is equal to 0. That is the standard form of quadratic equation where your a, b, and c are sets of real numbers and your a must not be equal to 0. Again, the standard form for quadratic equation is ax squared plus bx plus c is equal to 0, where a, b, and c are sets of real numbers and your a must not be equal to 0 or else the equation will become linear. So that's why your a is not equal to 0. We can solve the quadratic equation, example, x squared plus 4x plus 3 is equal to 0 by factoring using the zero factor property. So are you excited to use the zero factor property? Okay, just chill. Let's define first what is a zero factor property. According to the zero factor property, if a and b are real number, and if AB is equal to 0, then each of its factors rather will be equal to 0. That's why we have it A is equal to 0 or B is equal to 0, where AB is equal to 0. Yes, exactly. So let's have an example applying the zero factor property in solving quadratic equations. So solve each equation by the zero factor property. What happened to my tongue? Why is it? I cannot pronounce it correctly. Just bear with me. So example, we have the equation or quadratic equation, 2x squared minus 3x plus 1 is equal to 0. So how do we solve it? Of course, the first equation can be factored as 2x minus 1 and x minus 1. So after factoring it, we can use the zero factor property by equating each factors equal, yeah, equating it, just put an equal sign, which is equal to 0. So we have it 2x minus 1 is equal to 0 and x minus 1 is equal to 0. Again, using the zero factor property, you are going to equate each factors to 0. How to equate? Just put equal sign, then 0 equals 0. So easy, right? Easy to follow. So we have it. Then after equating it to 0, then you're going to, yes, solve for your x. Then your x is equal to 1. And of course, the other x or the other root is equal to 1/2 by, how did we get it? Of course, we solve for your x using the equality, or the, yeah, the properties of equality in linear equations. So for this, yes, that gives you 2x equals 1, then divide both side by 2, that gives you 1/2. So I hope you can follow, and this help much. This will help you a lot to understand how to solve quadratic equations by zero factor property. The next is x squared is equal to 25. Then yes, you can rewrite your roots as 1/2 and 1, going back to the first given. So going back again to x squared is equal to 25, you can write it in standard form as x squared minus 25. And as you can see, it can be factored as, or using the sum and difference of the two squares, or factoring yes, factoring the two squares. So we have the difference of two squares rather. So we have it x plus 5 and x minus 5 is equal to 0. Then use the factor property to equate each factors into 0. So we have it x plus 5 is equal to 0, or x minus 5 is equal to 0. So you have it. Then solve for your x. That gives you x is equal to -5, or x is equal to 5. So easy, right? That is using the zero factor property. Now, we will go to the next objective that we have in this video discussion, to solve equations of the form of x squared is equal to k, where k is greater than 0. So when we say k is greater than 0, your k must not be equal to negative numbers. Just remember about that one. So to solve equations of the form of x squared is equal to k, where k is greater than 0, we might also have solved x squared is equal to 9 as an example, by noticing that x must be a number whose square is 9. Thus, x is equal to square root of 9 will give you 3, or -3. This can be generalized as the square root property. So in solving equations or quadratic equation in the form of x squared is equal to k, where k is greater than 0, then you can use the square root property. So are you ready? Okay, I know you're ready, so let's start. Square root property, if k is a positive number, and if x squared is equal to k according to this property, then x is equal to square root of k, or it can be x is equal to negative square root of k. So in short, the solution set can be described as this, as you can see, a set of negative square root of k and square root of k, which can be written as positive and negative square root of k. Then this one can be, the positive and negative can be read as positive or negative, as how I read it, or you can read it as plus or minus. So I hope you are following. Now we will try to apply the most exciting part in this lesson, when we apply the steps or the property or the square root property that we just discussed in a given problem. Example, z squared is equal to 49. So of course, using the square root property, you get the square root of each sides or both sides of the equation. So square root of z squared and square root of 49 to eliminate the square, of course. Then after that, you have it z is equal to 7, a square root of 49, or you can have it as your value for your z using the square root property as positive and negative 7. So when you try to solve using the square root property, you have two values of your roots. It's either positive or negative, just like in z. Z is either positive and or negative 7. So for the next example, we have it applying the square root property. That gives you x is equal, or that will give you the value of your roots as x is equal to 2 square root of 3. Again, consider the positive and negative. So positive and negative 2 square root of 3. Okay, next is x squared is equal to negative 169. So using the square root property, that gives you that. However, negative or 169 is negative. Therefore, the roots is a null, null set, meaning you cannot solve its roots because it's a complex number or imaginary number. Since I did not discuss yet the imaginary number, so we will just set with the solution as a null set since the radicand is negative. So again, it can be solved using the complex number or imaginary number, applying it. But since we did not discuss it yet, so we will have our answer as a null set. For this, we have it. We can, yes, 3x squared minus 8 is equal to 88. You can transpose negative 8 to the right side of the equation. That gives you 88 plus 8, or applying the addition property of equality. So we have it 96, then divide both sides of the equation by 3. So we have it, Terence, x squared is equal to 32. Then applying the square root property, so we have it, square root of x squared is equal to the square root of 32. So that gives you 4 square root of 2. Again, square root property has two values. It's either positive or negative. So, sorry, positive and negative 4 square root of 2. Let's go over with our objective number 3. Exciting, okay? So objective number 3 states that we're going to solve equations of the form of ax plus b quantity squared is equal to k, of course, where k is greater than 0. In here also, we will use the square root property. So in each equation, in example number 2, as I showed a while ago, the exponent 2 appeared with a single variable as its base. So we can extend the square root property to solve equations in which the base is a binomial. So let's have an example, this one. So it's a square, correct? The p minus 4 is a square, is equal to 3. So we can use the square root property by squaring both sides. Yes, getting the square root. So that's how you do it. Get its square root. After that, this will become p minus 4 is equal to square root of 3. Then after that, applying the addition property of equality, or you can transpose it there, your p now is equal to p is equal to 4 square root of 3. Then, considering the positive and negative, right? Considering the positive square root of 3 for 3, applying the square root property and also the negative square root of 3. So you have two values of your p. So to solve this one, we have it p is equal to 4 square root of 3. Sorry, not 4 square root of 3, 4 plus square root of 3, or you can write it as p is equal to square root of 3 plus 4. And on the other side, we can have it applying, of course, still the same, applying the addition property of equality. Then you can solve your p as negative square root of 3 plus 4. So that's how you do it. Do not forget, when you apply the square root property, your right side of the equation will be positive and negative, just like how we do it in here. So you can have it, yes, you can have your final answer as you can see there. P is equal to 4 plus square root of 3, or P is equal to 4 minus square root of 3. So more examples, I guess. So you can rewrite it as 4 plus and minus square root of 3 if you want to combine them as one. So let's have another example using the square root property again. Get the square root. Then, of course, you have two roots for that. After applying the square root property, we have 5m plus 1 is equal to square root of 7, and 5m plus 1 is equal to negative square root of 7. So solve for your m. So to solve for your m, yeah, you transpose 1 on the right side of the equation by applying the negative property of equality. That's why we have negative 1 plus square root of 7. for the first root. And for the second root, we have it 5m is equal to negative 1 minus square root of 7. Then after that, we will divide both sides by 5. So your roots now, or your m, is equal to negative 1 plus square root of 7 all over 5. Or you can have it m is equal to negative 1 minus square root of 7 all over 5. Or you can combine your roots as negative 1 plus and minus square root of 7 all over 5. So next example, so first step again, you square it. But since your right side of the equation after squaring it or applying the square root property is negative, so that is imaginary. So meaning to say you cannot have a real roots. The roots are not real. In short, they are imaginary or complex numbers. So use formulas. The next is we're going to use formulas involving squared variables. So we are going to apply the rules that we have in this given example or in an application of quadratic equation. So use the formula W is equal to L squared G over 1,200 to approximate the length of a bass rather weighing 2.80 pounds and having girth 11 inches. So what will we do first? Of course, we are going to substitute the given. We all know that in here, your L, of course, we don't know your L. Your W, your weight is 2.80. That's why we have 2.80. 11, of course, we have it 11 as your girth, your G. So we have 11. So over 1,200 as constant. So what will you do to cross multiply it? We are going to multiply both sides of the equation by 1,200, or you can just cross multiply it. Then that gives you 3,360 is equal to L squared over 11. Then divide it by 11. Then that gives you, for a while, then that will give you uh, L squared is equal to 305.5, then get its square root using the square root property, then your L is equal to 17 point, yes, 0.48. So that is the approximate length of a bass weighing 2.80 pounds and having a girth 11 inches. So now my question, sir, you said that you're using the square root property, you have two answers. It could be positive or negative. Why is it's positive, your L? Since we're talking about your length, there is no such negative in your length. That's why we get its positive value. Okay? So I hope you got it correct. So the length of the bass is approximately 17.48 inches. Instead of using the equal sign, use the symbol for approximate, this one. Okay? As a replacement for this. So I hope you got something from this lesson. So I'm so happy to share my knowledge with you. So I hope you are learning so far in this video discussion about solving quadratic equation using the zero factor property and also the square root property. So I hope you will not forget the discussions that we have in this video. So please always remember that the essence of mathematics is not to make simple things complicated, but to make complicated things simple. Math is fun always and forever. So please subscribe my channel, share this one to your friends out there. And of course, yes, do not forget to subscribe if you did not subscribe yet, or if you haven't subscribed yet, rather, in my channel. So thank you for following. Have a good day. See you in my next video discussion.